Hi, in this video I will work out an example for the z-test between two proportions. The following example states, a professor believes that the proportion of students in her morning classes who are passing is greater than the proportion of students who are passing in her evening classes. She collects a random sample of 50 students in her evening classes and finds that 38 are passing. She also collects a random sample of 30 students from her morning class and finds that 26 are passing. Test a claim using a level of significance, another word for alpha, of 0.05. We will use P1 to represent the proportion of students who are passing the morning class. P2 is the proportion of students who are passing the evening class. H naught, the two P's are equal. H sub 1, P1 is greater than P2. That's our claim. We draw the normal distribution. It's a right-tailed test. We look up the critical value, 1 tail 0.05. 1.65 is the critical value. We calculate the sample proportions. So P hat 1 represents the morning classes. 26 out of 30 pass. We'll round to 3 decimals, 0.867. P hat 2 represents the sample proportion for the evening class. 38 out of 50, 0.76. We also have to calculate P bar. We take x1 26 plus x2 38. That's 64 divided by n1 30 plus n2 50, 80. We divide to get 0.8. Q bar is 1 minus 0.8, 0.2. And now we're ready to calculate the test point. We have the difference in the sample proportions minus the difference in the population proportions, which is 0, divided by the standard error. We plug that information into the calculator. Let's key it in. So we have 0.867 minus 0.76, close the parentheses, divided by the square root, and I keep everything in the square root, so 0.8 times 0.2 times, and now I use parentheses, that's 1 over 30 plus 1 over 50. Close the parentheses. Hit enter, and that's going to round to 1.16. Now it turns out the TI calculator has a built-in function, so we can use that as well to compute the test point. Let's do that. Click on Stat, go to Test, and we go to option 6, the two proportion z-test. X1 is 26, N1 is 30, X2 is 38, N2 is 50, and our claim is that it's greater than, so we keep that the same, and press calculate. We get Z is equal to, now this is a little bit more precise because it's not rounding at any stage. It's 1.15, but we'll stick with the 1.16. But when you use the built-in function, you may get values that are slightly different, but you'll still get the same result because 1.16 falls in the non-critical region. Thus, we do not reject H naught, and then we would state that there was not enough evidence to support the claim. Thanks for watching this video.